In lesson 9.8, we learned how to factor out a common binomial and also factor by grouping. We're going to start by factoring out a common binomial. In example A, you'll notice that each of those terms has a common factor. They both have an x minus 4 as a factor. So if I factor out x plus 4 from each of those terms, I'm left with 2x and a minus 3, and that becomes our second factor. The answer to this problem is the quantity x plus 4 times the quantity 2x minus 3. In this second example down here, each term does not have a common binomial factor. However, they're very close. If we were to take this 2 minus y and rearrange it so that the y came first, negative y plus 2, it's easier to compare it to this y minus 2. They're not the same, but we can make them the same by factoring a negative 1 out of negative y plus 2. If we factor a negative 1 out of y, negative y, it becomes positive y. If we factor a negative 1 out of positive 2, it becomes negative 2. So now we have the same thing in each set of parentheses, y minus 2 and y minus 2. But this negative 1 that we factored out needs to get multiplied by the 5 that was already there. So we have negative 1 times positive 5 is negative 5, and our new factor of y minus 2. We put that with the beginning part of this problem that we did not change. And now we can factor it just like we did in the previous problem. If we start by factoring out the y minus 2 that's in each one of those terms, we're left with 3y squared and a minus 5. That makes up the second factor. The answer to this problem, y minus 2 times 3y squared minus 5. We also learned how to factor by grouping in lesson 9.8. Grouping means that we're going to put two sets of terms together so that we can factor something out of them. In this first example, we're going to group these into pairs. I put parentheses around the pairs that we're going to factor together. In this first set of parentheses, the common monomial factor that each of them has is x squared. If I factor out x squared, I'm left with x plus 3. Everything's positives, pluses in this problem, so we keep the same sign throughout. In the second set of parentheses, I can factor out a positive 5, and I'm left with x plus 3. You should notice that these numbers in parentheses are equivalent, or they can easily be changed to be equivalent. So now I factor out an x plus 3 from each of those terms, and I'm left with x squared and a plus 5. That right there is our answer to this polynomial that we solved by grouping. Grouping works when you have 4 terms in your polynomial. We haven't done any other problems that have 4 terms. This last example is a little bit different because we now have negatives to consider. We still set up the problem the same. We're going to group it in parts of 2. However, when there's a negative right here, essentially we factored this negative out of the negative 5a, and we put it outside the parentheses. But that means we also have to factor the negative out of negative 65. To do that, really we're just changing it to a positive 65. If you had a negative 65 and you divided it by a negative, it became a positive. So now that we've changed the signs, let's factor out of each group. In the first group, I have a squared is our monomial factor, common one. We're left with a plus 13 minus, in our second grouping, we factor out the number 5, and we're left with a plus 13. Again, we should notice that this and this are the same. If you ended up with a negative sign right here, it's probably because you did not change this to a plus before you started the problem. All right, now we group or factor out again. We factor out an a plus 13 from each of those terms. And we're left with a squared and a minus 5. The answer to this problem is a plus 13 times a squared minus 5.